Hey, math friends. So our learning target today is that I can calculate the percent of change. Whoops. I can calculate percent of change. So the change in a situation is when we would be identifying this. And this is really mathematically the only time that you could have more than 100%. If we threw out the idea of extra credit on a test and things like that, when people say 110%, that's not really realistic unless there's a change that occurred. So then you can have more than 100%. So let's dive in. So what is percent of change? It's the percent that a quantity changes from the, I might not be able to get this to work now, the original amount. So we have the original amount. First of all, we identify is that an increase or a decrease that happens over time, and then we calculate that into a percent. So the formula for percent of change is pretty simple actually. So percent of change, would be great if I could get a pen to work here. Oh boy, I'm stuck. Percent of change is the amount that it changes. Now this could either be an increase in quantity or a decrease. Just figure out how much it changed and then write it over the original amount. The key is that we put the original price or amount in the denominator, and then we simply just take cross products like we've been doing. Some things that are helpful, a lot of kids will say that they think it's, so I just said Ms. V's trick, is that you take the bigger number first. And the reason why they think that's easier to figure out when you're subtracting is it avoids a negative. Negative would just mean decrease, right? But a lot of kids will say just it's easier if you take the bigger number first because then you don't have a negative, blah, blah, blah. Okay, so increases in the real world. Well, the cost of a house increases over the course of time. The cost of brand new cars increase over time, the cost of brand new cars. The cost of gas typically increases over time, and so on. So those are things that increase over time. Now, when I say a car, I mean like the value of a brand new car. So when I was a kid, the price of a brand new car is very different than when you want to buy that same type of car. Decreases that happen over time are when there's a sale. We talked about that in yesterday's lesson. When there's a sale, we call that a discount. That's definitely a change in price. Also, like used cars, they decrease over time. Used anything really decreases over time. So the value of it decreases. All right, so let's take a look at some examples. So here's our first example. Skyview currently has 813 students. Now, that is the number that I used last year or maybe 2 years ago, so that could be a little bit outdated because of our situation. I'm not quite sure how many students Skyview has exactly. 813 students. Next year, our population is projected to be 776. So now I just have to figure out the change in the numbers. So the change in the students is from 813 to 776. And again, the trick is to take the bigger number first, only because then you're not dealing with that negative. And you definitely can use your calculator. So there's a change of student. I'm going to use this symbol. That symbol in math means change. There's a change of 37 students. Currently, it's 813. Next year, it's projected to be 776, which means that it is a decrease of 37 students. Okay, so once we know that, we just say that we're going to decrease by 37. What was the original? What was the first in the course of time, like on a timeline? This year or next year? Which one happens first? This year. So that's what we mean by original, the oldest thing. And then we just simply take cross products. So we solve taking cross products, so we get 813x equals 3700. Divide both sides by 813, just like we've been doing a gazillion times. And what do we get? What do we get? So we will find that we are going to have a 4.55% decrease in the student body at Skyview next year. Now these are made up numbers, so that could be very different, but I needed some numbers to slot in for the example. So that's percent of change. How much does it change? Over the original amount. Let's try a new example. My 8-passenger sports car, also known as a minivan, you might call it a minivan, but I thought it was a 8-passenger sports car, boom, was $23,000 when we bought it brand new in 2006. The value of that car is probably now worth, I'm going to even change this slide. Well, let's just leave it for simplicity. It's definitely less than $3,000. So what is the amount that it changed? Well, it was 23,000 and it went down to 3,000, which means it was a $20,000 yet again decrease. I did 2 decreases in a row. What was the original price of the van? The price of the van at the beginning was 23,000. Now taking cross products and solving to get our answer. Do it, do it, do it, do it, do it. So you should say that the change was, I'm going to round to the nearest whole. I'm going to get rid of the decimals. It's a pretty messy decimal. 87% decrease in the value of my car. 87% decrease. Okay, next question. Hopefully this is an increase problem. Otherwise, I'm going to have to, yeah, let's do this one. All right. When Mrs. Volkman bought her White Bear Lake house in 2000, this is a real story. The cost of the house we paid was $148,000 when we bought our house in White Bear Lake. We sold that exact same house 8 years later for the cost of $215,000. What was the percent of change on that sale? So the first thing is we want to figure out how much did it change. So those are the two numbers that we're dealing with. So we have 215 minus 148. So the amount of change would be 215,000 minus 148,000, the two prices, is a 67,000. Yay! Increase in money for the sale of our home. So we made $67,000 cash on the sale of that home. Now anybody that's bought a house would be like, well, that's not totally true because you have to pay the realtors and the closing costs and all these fees. So there were additional dollars that had to be taken out of the $67,000 profit that we made, but on paper, that's what it looks like. So $67,000 is the increase that we made on the sale of our home. The very first price of our home was $148,000 over time. Remember the timeline. I'm having a hard time with my pen right now, you guys. So we take cross products. Sometimes it works and sometimes it doesn't. I'm using different stylus at different times, and I think this stylus is burning out. All right. So taking cross products, I'm totally out of room, so I'm going to have you just trust me that I'm trying to calculate that behind the scenes here. Go ahead, pause the video and give it a shot. I'm going to round to the nearest whole percent. So we would say that it's a 45% increase in the sale of that home. So that was super good news for us. Super, super duper good news for us. All right. So now, hey, remember that house that Ms. Volkman sold in White Bear Lake? Well, the bad news is she wanted to sell the house for $250,000. But she only got $215,000. I couldn't remember what my own question said. So that house, our for sale sign, this is a very interesting thought process as well. So the for sale sign in our yard, we were trying to sell it for $250,000. I'm going to use K for 1,000 just because of space. That's what we wanted. That's what the for sale sign said. But the person we just mentioned, how much we sold it for, said that they would only give us $215,000. So unfortunately, we didn't get what we wanted. We got less than we wanted. We still made the $67,000, but we didn't make what we wanted. So there's definitely a decrease that happens here. So if we subtract these two numbers, we can see that it's $35,000 less than we wanted. So we'd have $35,000. The decrease in the sale that we wanted on our first sale sign, we had to go less if we wanted to sell it. The original price that we had on the for sale sign was $250,000. Oh, tears, we didn't get that. We only got $215,000. So taking cross products then, what was the percent of change or the percent of loss that we took on what we wanted to what we get? Oh, I think I just broke my stylus. So we have 35,000 divide by 250,000. Which means that we had took a 14% decrease in price. I'm going to pause the video a minute because I broke my stylus. All right, let's try it again. Let's see how this goes. So 14% decrease in the price that we wanted. That's our percent of change. All right, let's take a look at some other example, and then we'll be out of here. I think that one's a little bit confusing. Let's try this one. All right. Last week you finished level 2 of a video game in 32 minutes. Today you finished level 2 in 28 minutes. So the same level, there's a change that happened. Because of space, I'm going to write down here. So 32 minutes was your old price or your old rate. 28 minutes is your new rate. So there's a change in your rate by 4 minutes. You had a decrease of 4 minutes. Yay, good for you. Although, are you playing video games too much? That would be my next question. I do have kids that love to play video games as well living here. So, with that said, the original rate that you had was 32 minutes. That was your first rate when we kept track. So you decreased by 4 minutes. Your first rate was 32. And then we take that over 100. I'm out of space there, so I'm going to snatch on my work. So your job is to figure out what percent of change did you have. So you should be coming up with that you had a 12.5% decrease in your rate. Your rate changed by 12.5%. So you were getting faster by the rate of 12.5%. Yay for you. All right, I think last problem of the day would be here. The bar graph shows the softball players' home run totals. What percent of change occurred from 2007 to 2008? So 2007, we had 28 home runs. 2008, we had 20 home runs. 8 is the change. The change is 8. Again, that's the symbol we use in math for change. Did we increase or decrease over the course of time from 2007 to 2008? Decrease of home runs. So that would not be good for our softball player. So a decrease of 8 over the original that we recorded was 28 in 2007. That's the time we were asked about. I get there are other timelines on the graph. What percent of change is that? So we take cross products to solve. We get 28x equals 800. We divide both sides by 28. Boom. And so we end up with x is equal to, I'm going to round to the nearest percent, 29%. I know that there's a decimal there. It's 28 point something. A 29% decrease in home runs. So our learning target for today is about percent of change. So when you have a percent of change, I'm going to use this symbol for change, you just need to find how much did it change. Identify whether it's an increase or a decrease, and always put the original on the bottom, like the thing that happened first, and then just turn it into a percent, x over 100. It is possible, although I don't think we got any greater than 100. This is the only time in math that it is okay if you get greater than or equal to 100%. That is the only time, well, I guess you can always get equal to, but greater than 100%. Just be aware of that because there is a change happening there, like if gas prices or prices went up. All right, that's it for today on I Can Calculate Percent of Change. Have a glorious night.